See this question now. This is the previous year question of CBSE, and one thing you have to change, this question is wrong given by CBSE, and I will change it. Here this negative is not the negative, this is positive. This is the positive and here will be negative. Positive and here you will write negative. Just see the question. They are saying the potential difference across the terminals of a battery is 10 volt. The potential difference across the terminals of a battery is 10 volt. So potential difference across the terminals of a battery is 10 volt, and when there is a current of 3 ampere in the battery from positive to the negative terminal, okay, when the current is 2 ampere in reverse direction, the potential difference becomes 15 volt. What is the internal resistance of the battery? So okay. There is a battery. Suppose this is the battery given. This is the battery given. And this is the positive terminal of the battery. This is the negative terminal of the battery. And the potential difference across the terminals of the battery is 10 volt. And potential difference is given. Okay. And they are saying when there is a current of 3 ampere in the battery from the positive, here you have to write the positive because this question is wrong. From the positive to the negative terminal. From the positive to negative terminal, when the current is flowing, the potential difference is 10 volt, and some EMF, there will be some EMF of this battery, and there is some internal resistance also of this battery. We already know that because in battery there the battery have the internal resistance also, but we have given the potential difference of 10 volt. So what is the, and this is the condition of charging or discharging? This is the condition of discharging of a battery. Discharging. Why discharging? Because you can see here the current is flowing from positive terminal. Oh, sorry. The current is flowing from positive terminal to negative terminal, not like this. Like this. From positive terminal, the current is emerging from positive terminal and terminating at the negative terminal. So this is the condition of discharging. And for discharging, what is the equation of potential difference or terminal potential? V is equal to E minus IR. When you will check your notes, you will get the answer. When you will check your notes, you will get the answer. What is the terminal potential when the cell or battery is discharging? So this V is given as 10 and this E we don't know. I, what is I? They are saying current of 3 ampere is flowing. in this condition, the current of 3 ampere is flowing. So what you will write here? Minus 3 into R. So this will be your equation number 1. Okay. And after that they are saying when the current is 2 ampere in the reverse direction. Reverse direction means this time the current is from positive to negative. Now reverse direction. Reverse direction means the current will be from negative to positive. Negative to positive. And this means the charging condition. So same battery you have, and this battery have internal resistance R and EMF E, and this is the negative terminal, this is the positive terminal, and now this time the current is flowing like this, and the amount of current is given as 2 ampere. So this is the charging condition, because here the current is leaving the negative terminal and entering the positive terminal. So you can say the current is from negative to positive. So what is the terminal voltage or potential difference for this condition? V is equal to E plus IR. We have already written this for the charging of cell or battery, and they are saying in the when the current 2 ampere is in the reverse direction, the potential difference becomes 15 volt. So this time V is given as 15 volt, and E plus 2 into R. This is your equation number 2. So now you will solve both the equations, equation 1 and 2, you will get the answer. So how you will solve these? This is equation number 1. This is equation number 2. Now you have to solve both these. So what you should do, you should subtract both the equations. You should subtract both these equations. Subtract means subtract this 10 minus 15 means you will get here 5. And when you will subtract E minus E, you will get 0. You will get 0 here. And when you will subtract this minus 3R and minus 2R, this will become minus 5R. Okay. So you have minus 5 is equal to minus 5R, and minus cancel. R you will get 5 divided by 5 is equal to 1 ohm. So this is our answer. You can see here they are asking what is the internal resistance of the battery. So internal resistance means small r is the internal resistance, and internal resistance of the battery is 1 ohm. Okay. And please remember that here you have, this is not the negative, this is the wrong question given. So you can change it. Here you have to write positive, here you have to write negative. Then this question will be okay. So here you will write positive, here you will write negative. And you can get these questions from the portal. Actually, these questions I have given for the assignment. So Matthew, Nawal and Nafisa, have you got this answer?
Yes, sir.
Means you have to just apply the equation of charging and discharging, and you will get 2 equations, and you will solve those 2 equations, you will get your answer. So next question is this. I will take. Now see this question. This is asked in 2010, and this, believe me, this is very easy question. Very easy question. Why? See this. Why I am saying this is a very easy question. They are saying three cells of EMF E, 2E and 5E having the internal resistance R, 2R and 3R. Means this have the internal resistance R, this have 2R, this have 3R. Okay. And a variable resistance, here a variable resistance is connected. Shown in figure, find the expression for the current. We have to find the current. We have to find the current I. We have to find. And what is current? Current is equivalent EMF divided by resultant resistance, equivalent resistance, or you can say resultant resistance. This is the value of current. So first you have to find this E equivalent, then you have to find this R equivalent. So what is E equivalent? This is the series combination of cell. This is the series combination of cell. You can check your notes also. This terminal is positive, this is negative, this is positive, this is negative, this is positive, this is negative. Means here negative terminal of one cell is connected to positive and negative terminal of one cell is connected to positive. So this type of combination is known as the series combination of cell. Series combination of cells. So what is the equivalent resistance? How you will calculate the equivalent resistance in series combination? You will just add all the EMF. E, you will add this plus this plus this. E plus 2E plus 5E. You will get 8E as the equivalent EMF. And how you will calculate total internal resistance? You will add this one and this one, means R plus 2R plus 3R, because this is series combination. And the answer will become 3 to 6 and 1 7R. No, so 6R. 3 and 2 5 plus 6R. And one more resistance we have. This R. So when we will find the total equivalent resistance, then this will be R equivalent plus this capital R, and this will become 6R. I have just put the value of this equivalent resistance 6R and this plus R, and we will get the value of current. What is current? E equivalent divided by R equivalent. What is E equivalent? E equivalent is, you can see here, 8E. What is R equivalent? 6R plus capital R. This is your answer. And you will get the 3 marks. See how easy this question is. Okay, and this question is little bit lengthy for you, and I want your concentration on the screen, and please focus here. This question is something different. First tell me, which type of combination of cell is this, Matthew? Is this series combination of cell or parallel combination of cell?
Series.
No series, na. See here, this is
Never mind, it is parallel, yeah, because
this
if
is
you take
parallel,
I1
na,
and I1
because
together,
okay,
yeah.
this is parallel because there are many ways to find, because here these cells are connected end to end. These cells are connected end to end, and we have not discussed the parallel combination of unequal cells. We have discussed the parallel combination of equal cell, and this question is from the parallel combination of two unequal cells. So see how I will solve this question. This question is taken from the NCERT, okay, by CBSE. So this question appeared in 2008, 2010, 15, and 2010 and 2011. Means many times this question have been appeared in the examination. So now first see here on this. See here, this I is dividing I1 and I2. This I is dividing like I1 and I2. So first write the equation of current. I is equal to I1 plus I2. Now this is positive, this is negative, this is positive, and this is negative. Now you can see from here the current is from positive to negative. Current is leaving the positive and terminating at negative. So this so now Nawal, will you can you tell me this cell is in the charging condition or in the discharging condition? This cell.
It's discharging.
Very good. Very good. This cell is in discharging condition. Now Nafisa, you will tell me. Here the current is leaving the positive terminal and terminating at the negative terminal. This cell is charging or discharging?
Charging.
No, no. This is discharging because
Discharging, yes, sir.
yeah, this discharging because the current is from positive terminal to negative terminal, from positive terminal to negative terminal. Okay, so this cell is again discharging. So can we write the potential difference equation for this? So we can write the potential difference for cell 1. V1 is equal to E1 minus I1 into R1. For V2, you can write E2 minus I2 into R2 because both cells are discharging. So we have the equation V is equal to E minus IR. So I have applied this equation on both the cells. Okay, and you know that already these two cells are connecting in parallel. In parallel combination, the potential difference will remain same. The difference of potential will remain same. Means this V1 is equal to V2 is equal to V. Means both are same because this is a parallel. This is parallel combination. So you can consider V1 equal to V2 and I am considering both potential differences as V. So I can write the equation for V1, V instead of V1, now we will put V. V is equal to E1 minus I1 into R1. Okay. And here you can write V is equal to E2 minus I2 into R2. Now here this question have some calculation. So I am telling how you will solve this question. We have this equation number 1. What we will do, we will just calculate the value of I1 from this and I2 from this equation and we will put here. So just calculate I1. So here I am calculating V minus E1. I can write this as, this will become minus I1 into R1. So when I will calculate I1, then I will get E1 minus V divided by R1. Similarly, when you will calculate I2, you will get E2 minus V divided by R2. Now put I1 and I2, put value of I1 and I2 in equation 1. What is the equation 1? I is equal to I1 plus I2. This is the equation 1. Now put value of I1. I1 is this E1 minus V divided by R1. So I am putting it. Okay. So this is I1. So plus I2 you can put here E2 minus V divided by R2. Now the whole part is calculation part. So for I can write this expression can be written as E1 by R1 minus V by R1. We can write this. This can also be written as E2 by R2 minus V by R2. And this is I. So now take common terms aside. So here we have E1 by R1 plus E2 by R2, and this will become minus B. I have taken this common minus B, and I will get 1 by R1 plus 1 by R2. Okay. Now further calculate, take the LCM here. Now calculate these two terms. When you will calculate these two terms, you will get R1, R2, you will get here E1 into R2 plus E2 into R1, and when you will calculate this, you will get here R1, R2, and here you will get R2 plus R1. Now from here we will find this V. We will find this V. So I can write this as I minus E1 R2 plus E2 R1 divided by R1 into R2. Okay. And we have minus V R1 plus R2 divided by R1 R2. So now what we will do? We want to calculate this V, na? We want to calculate this V. So first take common minus from all these sides. So you will get this as E1 R2 plus E2 R1 divided by R1 R2 minus I is equal to, this minus will be cancelled out, and this will become R1 plus R2 divided by R1 into R2. Okay. Now what you should do here, you can solve this V with, there are two ways to solve. Multiply both sides with R1 and R2. When you will multiply both sides with R1 and R2, R1 and R2, here also R1 and R2 you will multiply. So you will get this cancel out, and you will get this. No. Oh. So just multiply it, no problem. Okay. Now what you will do, you will multiply this R1 R2 to this. So when you will multiply this R1 R2 to this R1 R2 and this R1 R2 will be cancel out. You will get E1 R2 plus E2 R1, and when you will multiply this R1 R2 with this I, so this will become I into R1 into R2, and here we have, this will cancel out, V into R1 plus R2. Now we want to calculate V. So how we will calculate V? So V is equal to E1 R2 plus E2 R1 divided by R1 plus R2, and here we have I into R1 R2 divided by R1 plus R2. So this is the final equation we have. So we can replace this equation with as E equivalent minus I into R equivalent, means small r equivalent. R equivalent. So suppose this is the equation second, this is equation third. When you will compare equation second and third, you will get your answer E equivalent. You will get this. This is the E equivalent. You will get This is the value of E equivalent you will get, and for R equivalent you will get this. This question is based on the calculation. Calculation is lengthy, otherwise this question is easy. So this is your answer. So this is the final answer that asked in the question. So see here, they are asking just deduce the expression for the equivalent EMF. Equivalent EMF we have to find, and the equivalent internal resistance of a cell which can replace the combination between point V1 and V2. So you can just replace this combination. You can just make the equivalent circuit of above like this. You want to make it. So this is the cell and this is E equivalent and this is R equivalent. This is positive, this is negative, and current is going like this. Okay. So just note it down all the questions, all of you. And this question I will say is a good question. Question number 34. Just note it down. And if you have any doubt, all of you, you can ask me.
No, sir, no doubt.
Means these questions are looking like very complex question, but these questions are very easy questions. We are doing nothing. We are just calculating. Here, these questions are based on the calculations only. So formula is same. We are applying the same formula every time. We are applying the same formula. But for the calculation point of view, some things are different. Okay. And for improving your calculation, you have to practice the questions. You can see this formula you already know. You already know all the formulas. You cannot say me I do not know any of the formula. This question is easy. I will say this is you already know current is divided like this formula, this formula. I have not applied any formula, but the part of the question is calculating here. So this is looking like lengthy question, but okay, just note it down. And I think that question will be of 4 marks. Just note it down and just change the question. This is positive to negative terminal. The equation of charging and the discharging of a cell are very important. If the cell is charging, the potential difference across the terminal will be V is equal to E minus IR. If the cell is discharging, if the cell is charging, then you will apply V is equal to E plus IR. If the cell is discharging, you will apply V is equal to E minus IR. And also one thing is also important, the direction of the current. If the direction of current is from positive terminal to negative terminal, so the cell is discharging. If the direction of current is from negative terminal to the positive terminal, so the cell is in the charging condition. Written? Should I scroll down?
Yeah, sir.
Yes,
All
sir.
of you? Okay. Just write it down. And you will find same question in your exam with changed data. Data will be changed. I will not say the same question will be there. That data will be same. The data will be different, but the procedure of solving the question will remain same. From the cell, from the topic cell, combination of cell. And this 5 by 5 is 1 ohm. That is why I am saying revision again and again. Revision is very important, because when you will not revise the things, you will forget the things. You will forget this formula also. Then there will be a problem for you. At least we should know basic formulas. What is the formula of charging of a cell? What is the formula of the discharging of a cell? What is the direction of the current when the cell is in the charging condition? What is the direction of the current when the cell is in the discharging condition? So these things we should know. Scroll down.
Wait, sir.
Wait or scroll down.
Wait 1 second.
Okay. No problem.
Yeah, sir. You can scroll.
Okay, Nawal, should I scroll down?
Yes, sir. Yes, sir.
Okay. And you can get the question from the portal. This question you can get from the portal. Okay, so you can write only answer because it will take time to, because these are the question of your assignment that I am solving. See, this question is looking very big, but see the solution, very easy question. Just copy the answer only. And you can get these questions from the portal. And after this, we will discuss the mixed combination of the cells. This topic cell is very easy topic. And I will say this is the hardest question of the cell. Hardest.
Done, sir.
Then, okay. Nafisa, completed?
Yes, sir.
Nawal?
Yes, sir.
Okay, good. Just copy this. Only answer. And one thing is very important. When you will solve the questions at your home, so try to do the things that solve the question by yourself. Don't see the formula in the copy. Don't see the solution in the copy. Try to think by yourself. Okay, when you are solving the question. Because in exam there will be no book, there will be no notes. And believe me, we are just studying a fraction of physics. Means this physics of 12th class is nothing. When you will go in the higher level, to the higher level, like the physics will become very tough. And this physics is very basic physics. But I know that you are getting problem, you may get the problem in the calculation part. Means when there are the equations, two equations, you are getting difficulty in solving the equations. But with the practice, you can do that. Parallel combination, this thing I have told you first in the capacitor, and after that I have told you when we are studying the parallel combination of resistance. And this is the third time I am telling here. In the parallel combination, the potential difference will remain same. Potential, not the potential, potential difference of potential between 2 points will remain same. And potential difference, voltage and the terminal potential is same thing. We have discussed this also.
So can you scroll down?
All of you, should I scroll down?
Yes, sir. Scroll down.
Nawal?
Yes, sir.
Okay.
Sir, for the cancellation part, why
Yeah.
is the left hand side not cancelled?
This
The
na this you are
balance.
saying na
Yeah.
this thing na
Yes.
actually I have skipped one step here. So next step is like this. See here. Uh, when you will multiply this R1 R2 with this term when you will multiply, okay, so like this will become like this R1 R2. When you will multiply with this, it will become E1 R2 plus E2 R1 divided by R1 R2. Okay, this is the one term, and here is I into R1 into R2. So this I have cancelled, but I have not shown this step in the here. Okay, so that is why I have written this E1 R2 plus E2 R1 minus I1. Okay, this is the
Yes,
next
sir.
step. I have just skipped this step to save the time.
Yes, sir. Okay.
Yeah.
Sir, you can scroll down.
Hold on. Okay. This is the end. This is the equivalent circuit you can
Down, sir.
write. Okay. So now all of you completed.
Yes, sir.
Okay.
Yes, sir.
Now we will have the mixed combination of cells. Mixed combination of cells means in this case cells will be connected in series as well as in parallel. Connected in series as well as in parallel also. So mixed combination of cells. This topic is very easy. We already know the series combination of cell. We already know the parallel combination of cell. But in this case, the circuit will be like this. The cell will be connected in series as well as in parallel. So just focus here. Just focus here. Okay. Just wait. I will tell each and everything. So identical cell. These all cells are identical. Identical means same EMF, same internal resistance. Same EMF, same internal resistance. Same EMF, same internal resistance. Now, in this row, this is a row. This is first row. This is second row. This is third row. Okay. So in a row, just remember this: small n number of cells are connected in series. Are connected in series. You can see here in this row, and there are n cells. In this row, there are n cells, and all that n cells are connected in series. Positive, negative, positive, negative, positive, negative. And this is another row. In this row also, n cell, there are n cells. In this row also there are n cells, and these n cells are connected in series. Here is another row, and in this row also the cells are connected in series. Okay. And we have, there are n number of rows here of identical cell, and finally we have connected this with an external resistance R. This is the external resistance R. And how many rows are there? 1, 2, 3, 4. Means m rows are there. M rows. Small m. M rows are there. So you can say there are m such rows. You can say identical rows. Small m such rows we have. And when you will calculate the equivalent EMF of this row, when you will calculate the equivalent EMF of this row, when you will calculate the equivalent EMF of this row, just I am modifying the circuit here. Okay. So can anyone tell me what is the equivalent EMF of this row? What is the equivalent EMF of this row? Means here n cells are connected. Okay, n cells are connected in series. We have already discussed. You will just add this E plus E plus E plus E n times, and you will get the equivalent EMF as n into E. And in series, you will get the equivalent internal resistance. You will add this R n times. You will add R n times. Then you will get N R. Same you will get here N E, N R, N E, and N R. Okay. So now you have equivalent EMF and equivalent internal resistance of one row, second row, third row, and there are M such rows. M such rows. Now you can see here this. Now this is the equivalent cell. So you can consider this as a one cell. This, and this, and all M equivalent cells are connected in parallel. Are connected in parallel with this external resistance. And if you want to find the equivalent EMF of parallel combination, and I have told you these cells are identical cells, then equivalent EMF will be an E, because this is the parallel combination, because this is AND to AND combination. This is a parallel combination, and you will say that here the equivalent EMF will be N times of E. Okay, because this is a parallel combination. And what about the equivalent internal resistance? So Matthew, what do you say about the equivalent internal resistance? How you will calculate that? Do you have any idea about that? Means you can see here that you have this one row, second row, third row, and you have M such rows. 1 by yeah.
1 by
Any
NR plus
Oh,
1 by NR plus
yeah.
1 by NR.
Okay. Okay. Just see. Okay. Just see. So this is a parallel combination. Now, in parallel combination, how we calculate the resistance? 1 upon R is equal to 1 upon R1 plus 1 upon R2, like this. Now, so if we want to calculate this R equivalent, so what we will do? We will
1
just
by NA, 1 by N, no,
yeah
1 by
1 by
NR, 1 by
1 by
NR.
NR, 1 by NR, 1 by NR, 1 by NR, and M times we have to add 1 by NR. 1 by NR plus 1 by NR plus 1 by NR, and how much time we will add this? M times. Means we will write this 1 by NR M times. So in denominator NR is same. So you will take NR as LCM, and now you will add this 1 plus 1 plus 1 plus this, you will add M times. And when you will add 1 M times, what is the answer? M divided by NR.
By
M into 1 na, you will get. So you can write M divided by NR. See this. See this. If you are adding 2 times, then you will write 2 into 2. If you will add 2 3 times, then you will write 2 into 3. If you are adding 1 if 3 times, then what you will write? 1 into 3. If you are adding 1 4 times, then you will write 1 into 4. You are adding here 4 times. And when you are adding n times, then what you will write? 1 into n. Okay. If you are adding 1 m times, then what you will write? 1 into m means m. Okay, so you should know all these things. This is mathematics. Okay, fine. So R equivalent will be this, reciprocal of this, n divided n R divided by m. So please remember this. This is the equivalent EMF in the mixed combination. This is the equivalent internal resistance in the mixed combination. Just copy this, all of you. We have calculated equivalent EMF and we have calculated equivalent internal resistance. And this chapter is just going to end in the 1 or 2 lectures, I think. One topic is left, Kirchhoff's law. Means Kirchhoff's law is, I will say, a good topic. When we will solve the numerical on this mixed combination, then your concept will be clear in a better way. And after this chapter, we will start magnetic effect of current.
So can you scroll down?
Yeah. All of you, should I scroll down?
Yes, sir. Down.
Okay, fine. I'm just zooming it out. Okay, now fine. This is the equivalent circuit when we have just connected the series equivalent resistance in series. Okay. Should I scroll down?
Yes, sir.
Yes, sir. Scroll down.
Okay, just note. So remember, if you are connecting, n cells in series and n cells in series, and there are m such rows, then the equivalent internal resistance will be like this: Re is equal to nr by m. So you have connected n cells in series in a row, and there are m such identical rows. I will use this formula in the next numerical, this formula and this formula.
Yes, sir. Finish.
Finish now? Okay. And today also I will give the assignment, and please try to solve the assignment. And I will give the assignment on the same topic. And when you will solve, whenever you solve the questions on the same topic, your concept will be very clear. Your concept will be, you can say that if you are doing the question on the same topic, then concept clarity will be better. Then you can get how this equivalent resistance is nr by m, and how you will apply this. And this is the formula I have derived. I have derived this formula. And when you will solve the question on this, you will get to know how we will apply this formula on the question. All of you complete it?
Yes, sir.
Yes.
Okay.
Yes.
Now let's see. Now let's see that we have calculated the equivalent EMF and equivalent internal resistance, and one thing more, we have this external resistance. So now I am just making another circuit. We have just calculated the equivalent now focus on this equivalent circuit. This is the equivalent circuit. Now we have what is the equivalent EMF? Ne divided by M. And what is R equivalent? Oh, sorry. This is Ne. Equivalent EMF is Ne we have. And what is this? This is NR divided by M. Equivalent internal resistance is this. And this is R now. And if I want to calculate the current, I, what is I? E equivalent divided by R equivalent. What is E equivalent? E equivalent is this. Ne. Ne is the E equivalent. And R equivalent will be R plus this. Or you can say this plus this. We have two resistances, NR by M plus R. So this is the total current. This is the total current in the mixed combination. I, what is I? I is the total current. Okay. So if I want to find the maximum current, or maximum current in the circuit, how many of you are of math student? Nawal, Matthew, and Nafisa. Means you have maths. in 12th? How many of you have maths?
I
Nawal,
don't have.
you don't have.
No, sir.
Okay. And Matthew,
Sir, I don't have maths.
you do not have math.
Yes, sir, I took psychology.
Oh, okay, no problem. So in mathematics of 12th class, we will have a topic maxima and minima. Maxima and minima. So if we want to find the maximum value of a quantity, then we use the maxima minima there. And maxima minima is nothing but we differentiate the function with respect to some quantity and equate that zero, and we will get the answer. So what we will do, I am not doing the whole step, we will just do this differentiation of current with respect to internal resistance and put is equal to 0, and we will differentiate second time it. This is known as double differentiation, and if this come out to be less than 0, then there will be maxima. And when you will differentiate the current with respect to internal resistance, you will get this. You will get this. NR is equal to MR, and you will get R is equal to NR by M. And what is this? This is the external resistance in the circuit. What was R? This R was the external resistance in the circuit. Total external resistance in the circuit. And what is this? This is the total internal resistance we have. This was total internal resistance. So if we want maximum current in the mixed combination, then the internal resistance of the circuit should be equal to the external resistance of the circuit. So so you will write when internal and external resistance are same or comparable, then we will have maximum current in the mixed combination of identical cell. Mixed combination of identical cells. Comparable means if you have an external resistance of 0.5 ohm and internal resistance of 1 ohm. So both these are comparable, you will say. Just copy this. Should I scroll down?
Yes, sir.
Okay. Just copy this. We always want the maximum current in the circuit. Okay. Not always, but means generally we want maximum. There should be the maximum current in our circuit. Okay. Should I move now?
Yes, sir.
Yes, sir.
Nawal? Okay, fine. So we have one question. And this is the last question of the class. So just first you can note this question, and this question will clear all your concepts. First note this question and then we will solve. Here 8 cells of 2 volt and 1 ohm internal resistance are given to us, and they are asking how would you combine them to get the maximum current in the circuit. Maximum current in the circuit if external resistance is 100 ohm first, and another if the external resistance is this, if the external resistance is this. Written?
Yes, sir. Finished.
Nawal?
Sir.
Okay, fine. Just see now. We have 8 cells. We are having 8 cells, identical cells we have. If not given 8 cells are identical, then you can consider the cells are identical. And having EMF, each having EMF of 2 volts, and each having the internal resistance as 1 ohm. Now, first part is, if we have connected one resistance of 100 ohm, if we have a external resistance of 100 ohm and this combination, this cells we have in our hand, so they are saying that how you will connect this cell, in which combination you will connect this cell so that you will get the maximum current. So just compare with the internal resistance of the cell. Here the internal resistance in first, when you will take this external resistance 100 ohm, then internal resistance we already have 1 ohm. So can you say that this external resistance is much greater than the internal resistance? And I have told you, you can check in your notes also, when the external resistance of a circuit is much greater than the internal resistance of the circuit, for the maximum current we prefer series combination. For maximum current we prefer series combination. Series combination means we will connect all the cells in series. We will connect all the 8 cells in series. So when you will connect all the 8 cells in series, what is the equivalent resistance? Ne. When you will connect all the cells in series, if you have n cells, suppose if you have n cells, now you can say n cells connected in series, and n is equal to 8, then you will write 8, and what is the EMF of each cell? 2 is given, so this will become 16 volt. And what is the equivalent internal resistance? You will just add the internal resistance of all the cells. We have 8 cells and each one cell have internal resistance 1, so you will add this 1 plus 1 plus 1 8 times, so you will get equivalent EMF, equivalent internal resistance as 8 ohm. Okay, and R we have already have. So what is the current? Current will be E equivalent divided by R equivalent. What is E equivalent? This is 16. And what is R equivalent? R equivalent is equal to the internal resistance plus this external resistance. Means 8 plus 100. So this will become 16 divided by 108 ampere. And if you want to make the circuit will be like this. Means this is 100 ohm, this is of 16 volt, this is of 8 ohm. So this is the first answer, and second answer is external resistance is given as 0.01 ohm, and we have internal resistance of each cell as 1 ohm. So here this internal resistance is much greater than external resistance. Then for maximum current we will prefer parallel combination. You can check your notes. I have written the statement also. So now you are connecting n cell, means 8 cells you will connect in parallel. You will connect 8 cells in parallel. So what is the E equivalent? What is the E equivalent? E equivalent will be E equivalent will be 2 volt. Okay?
Yes, sir.
Yeah. And what is R equivalent? R equivalent, when you will calculate, you will write 1 upon R equivalent is equal to 1 by 1 plus 1 by 1, means you will just add this 8 times. So you will get 1 upon R equivalent as 8, then you will get R equivalent as 1 by 8. Okay, so total resistance will be R plus RE, and what is R? 0.01 plus 1 by 8, and current will be E equivalent divided by R equivalent. E equivalent is this 2, and R equivalent, total R equivalent will be this 0.01 plus 1 by 8. This is your answer. Now for the third part, you have the external resistance of 0.5 ohm and internal resistance we have 1 ohm, means R is comparable to this 1 ohm, means you can say external resistance R is comparable 1 ohm. These both resistances are comparable now. This is 0.5, this is 1. So which combination you will prefer? You will prefer mixed combination. Mixed combination means you have 8 cells. Some of the cells you will connect in series, some of the cells you will connect in parallel. So suppose you have connected n cells in series. Okay, you have connected n cells in series. In a row, you have connected n cells in series. And for the mixed combination, what is the equivalent internal resistance? N by M into R. This is equation 1. And now we do not know N, we do not know M, we know R. So we will have R equivalent is equal to N by M. And this equivalent internal resistance is equal to the external internal resistance for maximum current. We have discussed that. So RE barabar R. So what is R? R is 0.01 is equal to N by M. So this is equation 2 you have. And total number of cell, if you want to find, then what is the total number of cell? M into N is equal to 8 cells you have. You have 8 cells. Oh, this is not 0.01, this is 0.5. External resistance here is 0.5. 0.5. And if you want to find, suppose you have connected n cells in series. Cells in series in a row, and there are m such rows. I have discussed the formula also. Okay, so m into n equal to 8. Okay, so from this equation you can get this can be written as 1 by 2. This is n by m. You can get m is equal to 2n. So just put this m is equal to 2n here. M is equal to, this is m is equal to 2n. When you will put here 2n into n is equal to 8. This is equal to 2n square is equal to 8. So this will become n square is equal to 4, and you will get n is equal to 2. And you have n now, you can find m. M is equal to 2n means 2 into 2 is equal to 4. So m is equal to 4. Means you will connect this in series. Means 2 cells you will connect in series, and you will have such 4 rows of series combination. Okay. And what is the current? What will be the current? Current will be total EMF, and total EMF will be NE divided by R equivalent. N is 8, E is 2, R equivalent is RE plus R. So 8 into 2. What is R equivalent? When you will calculate the R equivalent, you will get N by M into R. You will get N as 2 by 4. You will get this 0.5. So this is 0.5 and external resistance is also 0.5. You will get this 16. You will get 1. You will get this you will get 1. So the answer will be 16 ampere. Oh, give me a minute. Give me a minute. Just we have connected two cells in series, now. So our total EMF will be like this. Mm, This is 2. Okay, just note it down. Note down the answer. Uh, this is 4. This is not 8. This is 4. Means each cell have equivalent, means each cell have the EMF. So this will become 4. So answer will become 4 ampere. Now note it down. And in the next class, we will start the Kirchhoff's law. We have given the 8 cells, okay, and we have to decide whether we have to connect those cells in series, connect those cells in parallel, connect those cells in the mixed combination. And this thing will depend upon the external resistance. If external resistance is 100 ohm, then we will connect in series. If external resistance is 0.01 ohm, then we will connect those cells in parallel. If the external resistance will be 0.5 ohm, then we will connect those cells in mixed combination. So just note it down.
Yes, sir. Finish.
Okay, Nawal, should I scroll down?
Yes, sir.
Okay, just please note it down. So don't confuse in this. Okay. If you are getting any confusion, you can check your notes. I have already written all the things. What is the condition for the maximum current when external resistance is large, when internal resistance is large? Already written all these things.
Yes, sir. Finish.
Should I scroll?
Yes.
Should I scroll? Okay.
Sir.
This part of the question you will find little bit confusing. third part. And Nabal and Matthew and uh, Nafiza, if you want to ask something, means you have any doubt and all that, then please ask me. Okay?
Yes, sir.
And I want that before coming to the next class, revise your notes properly.
Yes, sir. Okay.
And I will give the assignment also on the same topic. So try to solve that assignment and we will solve in the next class. Finished?
Finish. Yes.
Okay. Just finish it and we will meet in the next class. When you will practice these derivation, these questions 1 or 2 times, believe me, this will become very, very easy. Very, very easy.